In this example, we want to graph the piecewise defined function f of x equals 0 if x is less than negative 3. Then it switches to negative x when negative 3 is less than or equal to x, which is less than 0. And then it switches to x squared minus 1 when x is greater than or equal to 0. So essentially we have three different graphs happening here at once. So let's look at what each one of these looks like by itself, and then we'll combine them all into the single piecewise function. We'll start with f of x equals 0, right? So let's graph this out by itself. Well, f of x equals 0 is simply the horizontal line 0, y equals 0. So it looks something like that. Next, let's recall what the function negative x looks like. That is a line of slope negative 1 with a y-intercept of 0. You can think of this as y equals mx plus b form. Well, that's negative 1x plus 0. So this is always, anytime you have x or negative x, it's always the perfect diagonal line that goes right through the center, right through the origin. Okay, so something like this. There we go. Finally, let's consider x squared minus 1. This one is a parabola that shifted down 1, so it looks something like this, or it comes through like so. It goes off, something like that. Now let's combine all these onto a single set of axes. The way the piecewise function works is it essentially splits this, in this case, into three different regions. So we have the stuff happening to the left of negative 3, between negative 3 and 0, and then to the right of 0. So we basically have 1, 2, 3 different regions going on here, corresponding to 1, 2, 3 different things happening on the graph. So in the leftmost region, when x is less than negative 3, our function is simply 0. Okay, so this is going to come along 0 like so. Whoops, let's really take it right along the x-axis there. And then it's going to be an open circle because it's less than but not equal to. Okay, then we switch to negative x in this middle region from negative 3 to 0. Okay, so we know what that looks like. It's a perfect diagonal line going down, and this is inclusive here at negative 3 because we have that equal sign on there, so it's going to be a closed circle, and then it comes down in a perfect diagonal here to 0, and then we have an open circle again because it's less than but not equal to 0, and then in the third region we switch to x squared minus 1. And that's going to be a closed circle again because we have x greater than or equal to, so we switch to a closed circle here and finish out with a parabola, something like this. Right, not an exact science here. Okay, now this is looking a little clunky, so I'm going to go back and clean this up, get rid of all my annotations. So we're left with just the graph. There you have it.